What is linear programming? How to convert linear inequalities to plot on the graph? What is the objective function, feasible region, and what is the optimal point? Linear programming is a mathematical method for determining a way to achieve the best outcome, be it the profit maximization or the least cost solution, subject to a number of limiting factors. For example, the company wishes to maximize profits. So the profit maximization is the objective function here. By the way, whenever you're given a word problem, always look for the key information. For example, the key information in the above long pair of text is $8 for X and $12 for Y. Rest is just extra words, so don't be intimidated by them. So first thing you can do is you can make an objective function. C is equal to 8x plus 12y. C is the maximum contribution and X and Y are the number of units produced by the company. Now comes the part about restraints. The company can only sell 6,000 units of X and 4,000 units of Y. You can convert that into equation. X should be less than equal to 6,000 and Y should be less than equal to 4,000. What about the limiting factors? Maximum raw material available is 24,000 units. X uses 3 units and Y uses 2 units. The equation would be 3x plus 2y is less than equal to 24,000. Similarly, when the limiting factor is of labor, the equation is x plus 2y is less than equal to 12,000. Once you have all the equations, you can start plotting on the graph. Turn inequalities into equalities. For x is less than equal to 6,000, no matter the value of y, the value of x will always be 6,000. So we turn that into a string at x is equal to 6,000. Similarly, for y is less than equal to 4,000, no matter the value of x, the value of y will always be 4,000. This time, we plot a straight horizontal line at y is equal to 4,000. For equations like 3x plus 2y is less than equal to 24,000, you can start by assuming the value of x to be 0 and solve the equation for y only. The value is 12,000. So the first coordinate is 0 and 12,000. Assuming the value of y to be 0 now and solving for x, the value of x turns out to be 8,000. Second coordinate is 8,000 and 0. Once you have two coordinates, you can plot a straight line on the graph connecting those two coordinates. Follow the same method for x plus 2y is less than equal to 12,000 and the coordinates are 0 and 6,000 and 12,000 and 0. All the lines are drawn. You need to highlight the feasible region. But now feasible region is the production combination that the company can achieve subject to all limiting factors. In the wave graph, it is bounded by A, B, C, D, and E. After that, you find the coordinates for each corner on the feasible region. For A, it's 0 and 4,000. For B, it's 0 and 0. For C, it's 6,000 and 0. Now, D is at the intersection of three equations. To find the coordinates, you need to simultaneously solve for two equations since there are two variables. The answer is 6,000 and 3,000. Similarly, for E, you need to solve for the intersecting equations and the coordinates turns out to be 4,000 and 4,000. Once you have all that, you can put the production combination in the objective function. In this case, it was C is equal to 8x plus 12y. The values of x and y at point A and the profit turns out to be $48,000. 0 profit at point B. For C, it's $48,000 again. At D, it's $84,000 and at E, it's $80,000. Maximum contribution is at point D, where contribution is $84,000. That's the maximum profit that the company can achieve subject to all limiting factors.